All right, so these are some characteristics of a logarithmic function when it's graphed. So a logarithmic asymptote is vertical. Now keep in mind that a logarithmic function is an inverse of an exponential function. So it's going to have the opposite of everything. So with an exponential function, the asymptote is horizontal. With a logarithmic function, the asymptote is vertical. And to find the asymptote, you set x minus h equal to 0. Now what does x minus h mean? We talked about it earlier. The inside. Good. This is the inside of the log function. What's inside the parentheses? So just a reminder of what that means. Okay? The x-intercept always exists, and you can set y equal to 0 to find it. Okay? And the y-intercept sometimes exists, and you can set x equals 0 to find it. And if it comes out something error in the calculator, it doesn't exist. The domain is asymptote driven, just like the range of exponential functions is asymptote driven, meaning that that's going to be the bounds of one of your sides of your domain, and the range is always negative infinity to positive infinity. So if you remember back to exponential functions, the domain was always negative infinity to positive infinity. So inverses are going to have the domain and range flipped, always. Okay, that's why. So let's go ahead and start solving this. So it says graph and identify the key features of each logarithmic function. We're going to start up here. So the first thing we want to do is we want to find our asymptote. So to find the asymptote, you're going to take x plus 1 and you're going to set it equal to 0. And when we do that math, what do we get x to be? Negative 1. Very good. Now we're going to wait on the domain. We're going to wait and see what the graph looks like. But the range is always negative infinity to positive infinity. Just like the domain of an exponential is always negative infinity to positive infinity. If you guys have a hard time seeing, feel free to move up. We have some extra seats up here. So now we are going to need to find some other information about this. Okay, we're going to need to use one of the two methods. I'm going to use the 1BP method. That's the second method that we practiced. Okay, and the method says to take what's inside of your log and set it equal to 1. That's the first rule. And when we do that, x is equal to what? 0. Good. And from there, we have to plug 0 into the log itself to find the y value. So we're going to have a little bit of crunch for room here. I'm going to move this over so we have more space. And y equals, well, we have to plug in 0 into the log for that. So that's going to be log base 2 of 0 plus 1. So what is log base 2 of 1? How would we find that? Do you guys remember? It's going to be log of what over log of what? Good, log of 1 over log of 2. So if you do that in the calculator, you're going to get 1 log divided by 2 log. And when you do that calculation, you should get 0. Okay? So for the sake of space, I'm not going to be able to leave all the work up. I'm going to have to erase it so we have room. But that's how you get it. So we got our first set of ordered pairs, 0, 0. You guys see that? So now we're going to do the next one. Okay? That should be an equal sign. So the next one, we're going to take x plus 1, the inside of our log function, and we're going to set it equal to, the next one we do is b. Remember you set it equal to b, your base. So what is the base of this log? 2. Which means x is equal to what here? 1. So then we have to plug that into the log to find the y. So it's going to be log base 2 of 1 plus 1 log base 2 of 2. Now, this one you can do in the calculator by doing log of 2 over log of 2, if you want to. But back in 6.3 we learned that there's a rule that if you take the log of the base, does anybody remember what it comes out to be? 1. So this one's going to be 1 for that reason. Okay? Alright, so the next one we do, we're going to take x plus 1, the inside, and we set it equal to b squared. So what would my base squared be? 4. So that comes out to be x equals 3. And then we need to plug it in to find y. So it's going to be log base 2 of 3 plus 1, which is 4. Log base 2 of 4 is equal to 2. So the answer here is 2. And you could do the math by doing log of 4 over log of 2, and you would get 2. So you can do your work by the calculator. You may go to the bathroom, yep. And the last one that we always do is we take our x plus 1, the inside of our log, and we set it equal to b to the what power this time? So we always set it equal to 1, b squared, and then b to the third. So what would b to the third power be? 8. So that's going to come out to be x equals 7, which would mean y equals 3. So I'm just going to tell you, I'll tell you the last one, but that's how you calculate it. So does anybody have any questions about how to find the y? You're plugging it into this. Alright, so now that we have our table values, let's fill in our table. So we have 0, 0. We have 1, 1. Oops. And we have 3, 2. And we have 7, 3. We also have our asymptote. What did we find our asymptote to be again? X. Good. X equals negative 1. So let's plot these. So it's going to be 1, 1. I mean 0, 0, 1, 1. 3, 2. That's 2, 2. 3, 2. And 7, 3. We plot our asymptote, which is at negative 1. And then we can connect it. So it's going to look something like this. And then once we have that, we can go through and find our x-intercept. So sometimes the x and y-intercept are going to be easy to find. When you want to find an x-intercept, you plug in 0 for y, and when you want to find a y-intercept, you plug in 0 for x. Now that's if you need to find it algebraically, but this one you can look at the graph. So where does my graph intercept the x-axis? 0, 0. And where does it intercept the y-axis? Also 0, 0. Good. Alright. So we also have to find our domain. Domain is all the possible x values my function takes on. And it looks like my graph goes from negative 1 to positive infinity, because it's going to the right over here. And it's stopping at the asymptote. Asymptote endpoint is not included. And now we're going to figure out, is my graph, let's see, where's my graph increasing from? Well, it's increasing on its whole domain, from negative 1 to positive infinity. And now we'll look at its end behavior. Okay? As my x values go to negative 1, because my x values start at negative 1, What happens to my function as they approach -1? Is it going down or up? Down. And as my function goes to the positive infinity direction on x, this way, what happens to the function itself? Is this function going up or down over here? Up. Positive infinity. So that is how you graph a logarithmic function. Yes?
Why does it say positive infinity for -1?
Oh, you're right. It should be negative. I said negative and I wrote positive. I apologize for that. Thank you. Do you guys have any questions for me? Okay. So this is something that is more of a calculus pre-calc topic, but I will just mention it to you. I'm not expecting you to know this. Do this on your own. But when we look at a number and behavior, when we look at a number instead of an infinity on it, there are times when we're looking at this -1. Now, at the red line, are we looking at the function on the right of it or the left of it? Where's the function located in terms of the red line? To the right of it. So sometimes you'll see them put a little plus there. That means that the function's on the right. So we're looking at it from the right side of that value. So I'm not expecting you to put that down. I mean, you can write it down if you want. I'm not expecting you to be able to do that, but I just want to mention it. So do you guys have any questions for me about that? All right. Let's try another one together. So the first thing we're going to do is we are going to find the asymptote. So to find the asymptote, you always take the inside of your function and you set it equal to 0, which gives me x equals -2. That's your asymptote. So I'll just kind of write that over here actually, just write x equals -2. But that's where it comes from. So now we're going to do our work. So the rule says to do the work, we do what's inside the log function, and we set it equal to 1. That's the first one we always do. That would give me x equals what? What's 1 minus 2? Thank you, -1. And then we need to find the y value. How do we find the y value? We have to plug in the x. Good, back into the log equation. That's going to be -1 plus 2 minus 1, right? So that's going to be log base 2 of 1 minus 1. Which comes out to be log of 1 over log of 2 minus 1. So we would do that calculation in the calculator. And we should get -1. And then we take our inside of our function. I'll do this in another color so you don't get confused. We take the inside of our function, and now we set it equal to what? What comes after 1? We set it equal to b, which is 2. Good. And that's going to give me x equals 0. And then we plug 0 back into the original function. So that's y equals log 2 of 0 plus 2 minus 1. That's log of 2 minus 1 now. What is log of its own base? 1. So 1 minus 1 is 0. So you guys understanding the work that we're doing to get the answer? Okay. You're just plugging it back into the equation to find that. So the next one we would do would be x plus 2, and we set it equal to b squared. What would b squared be? 4. So that would give me x equals 2, right? And that would give me y equals, I'm trying to do it in my head, let's see. 2 minus 1 would be 1. And then the last one we would do is x plus 2 is equal to b to the third power. What's b to the third power? Good. Which would give me x equals 6, which would give me y equals 3. So that'd be 2. So like I said, you're just plugging x into this equation to find y. Just evaluating it. So from here we have our ordered pairs now that we can plot. So it's going to be -1, -1, 0, 0, 2, 1, and 6, 2. And now we are going to plot these points. So -1, -1, 0, 0, 2, 1, and 6, 2. Now we want to graph the asymptote. So what do we find our asymptote to be? Good. So we're going to plot that. And it's going to look like this. So now we're going to go through and identify some fact key features of this. So the range is always -infinity to positive infinity, so that's an easy one. And that's the case for every log function. Now for our domain is going to be driven by the asymptote. It looks like it's going to the right of the asymptote, so it's going to be from -2 to positive infinity. Does this graph have an x-intercept? And where is it? Good. And it has a y-intercept also at? Good. It's increasing on its whole domain. It's increasing all the time. And the end behavior, as we look at x going to -2, so it's as it tries to hit the asymptote on the right side, it's going off to -infinity. So as we get closer to the red line, see how my function goes down as it gets towards the red line? But in the other direction, as my function goes off to the positive infinity direction, what's happening to my function on this side? It's going over here, it's going up. Slowly, but it's going up. So if I zoom this out for y'all like that, that would be the work for these two questions.